Hi, welcome to my new unit on quadrilaterals, and this is the first video which is on the definition of a quadrilateral. Definition of a quadrilateral. A polynomial is a figure with three or more sides made up of line segments. A quadrilateral is a polynomial with four sides. Notice we have four sides, four sides, four sides, and four sides. And this one is a B, C, D. Quadrilateral, which is above A, B, C, D, has consecutive vertices of A, B, C, D. A to B, B to C, C to D, and D to A. So this quadrilateral, when you name it, has to go in order. So when you start with a letter, you go around in that order. So if you start with D, you could go D, A, B, C, or D, C, B, A. But you have to follow one letter to the other. And we also have, these are consecutive vertices. Notice they follow each other. Non-consecutive vertices are, we could have non-consecutive vertices A and consecutive to A is B and D, so non-consecutive to A would be C, and if we have vertex D, non-consecutive, DA is consecutive, DC is consecutive, so D would be B. Okay, so we have established that consecutive vertices follow each other in order, and non-consecutive, notice, are across from but not next to. A side of a polynomial is a segment joining the consecutive vertices. So the sides are AB. Next side is BC. The next side is CD. And the next side is DA or AD. They're the sides of the polygon. A diagonal of a polygon is a segment joining the non-consecutive sides. So a diagonal is not a side. So the diagonals could be, if I leave Q, QR is a side, QP is a side. So one diagonal would be QS, this one. I put it in dotted, QS. Or you could go SQ. And another diagonal would be PR or RP. And some people put bars above them to indicate their segments. It's your choice, as long as you know what you're doing. So we have consecutive vertices, non-consecutive sides, and diagonals. Let's continue. What about a convex and a concave polygon? A convex polygon has its diagonals inside. A convex polygon has its diagonals on the inside. So if I leave here and draw this diagonal is on the inside of the polygon. If I leave this point, this diagonal is on the inside. So this is convex. And this one has many diagonals, just draw a couple. So notice this is a diagonal here. This is another diagonal here. So all the diagonals that I'm drawing, like this, there they are. All the diagonals are on the inside. So this is a convex polynomial. A concave polynomial has at least one diagonal outside of the polygon. And notice if you do FD, FD is on the inside. That's a diagonal there. But outside would be HE. So HE is outside, so this is concave. Think of a concave, as being like a cave in the ground, a hole. So there's an indent. And in this one, the diagonal outside would be A. So AB is a side, AT is a side, but AD is a diagonal, and that diagonal going from A to D is outside. So these are concave polynomials. All proofs that we'll do on quadrilaterals will be on convex polynomials. where the diagonals are on the inside, like these. Now, we also have types of quadrilaterals. Quadrilaterals are four-sided figures. So, if a quadrilateral is a four-sided figure, then we're going to call this one a parallelogram. A parallelogram has opposite sides parallel. This is a rectangle, and a rectangle has right angles. We're going to go over all these properties and get back to parallelogram. Parallelogram has opposite sides parallel. So this side is parallel to this one. This side is parallel to this one. A square has all sides equal, and it has all right angles. And this is a rhombus if you mark them all sides equal. Not a square because it don't have any right angles. And a trapezoid has at least or only one pair of opposite sides parallel. And a kite has two pairs of adjacent sides. So this side is equal to this one, and this side is equal to this one. So this is a kite. A kite has two pairs of adjacent sides equal, only two pairs. Note, each quadrilateral above has, all of these have only two diagonals. Notice, 1, 2, 1, 2, 1, 2. Down here, 1, 2, etc. Has only two diagonals. So we're just reviewing what a trapezoid is. A trapezoid, a kite, etc., etc. But more of these will be done later. So let's continue. Let's do some practice. Pause the video and see if you can work out these answers after looking over what I did on the first part. So here we go. Number 1, we have a quadrilateral here, T, F, A, E. Which vertices are consecutive to E? Consecutive to E would be T and A. Which vertices is non-consecutive to F? Consecutive to F would be A and T. Non-consecutive would be E. We have a polygon here, P, X, Y, H, T. And notice I went around in order, P, X, Y, H, T. You could go H, Y, X, P, T, but you have to go around in order. Name the diagonals from vertex T. So from vertex T, if I can't say TP or TH because that's a side. So TX and TY are two diagonals from T. So TX and TY are two of the diagonals, but there are many more. You got a PH, you got many more diagonals here. You got HX, etc., but there are many more diagonals in here. Number 3, we have two figures here. It says, which one is convex? Convex has all the diagonals on the inside. So convex is E, B, F, T. Notice I went around the order, E, B, F, T is convex. Concave, this diagonal's on the outside. There's a hole inside or an indent. So concave is A, P, H, I is the quadrilateral. So this is convex. All the diagonals are inside. And if there's one diagonal outside, then it's concave, at least one. Could be more in some figures. Number 4, I have the diagrams numbered 1, 2, 3, 4, 5. Which one above is a concave quadrilateral? So this is a triangle. So nope. Quadrilateral is 4 sides. This is 5 sides. Nope. And quadrilateral, 1, 2, 3, 4, 5. This is not a quadrilateral either. So these are the only two we can look at in terms of quadrilaterals. A concave quadrilateral has one diagonal outside. So that's number 5. Which one is a convex quadrilateral where the diagonals are on the inside is number 3. And number 5, we have a quadrilateral HPGI. Name the quadrilateral HPGI. Now you can name that any combination you want. You can go IGPH or HIGP. There are many names. Name its vertices. The vertices are H, P, G, and I are the vertices. The vertices are where, like in an angle, this is an angle, so this is the vertex of the, if you think of this as an angle, IHP, think of that as the vertex of the angle, but it's also the vertex of the quadrilateral. Name its sides. We'll go P, G, GI, IH, and HP. So notice I went around in order, but you didn't have to. You could name any one of these four sides first, but I just went around in order. Name is diagonals. It's convex, so the diagonals are on the inside. So the diagonals go from one vertex to a non-consecutive one, so that's PI. And another diagonal is HG. HG, notice you can't say HI because it's a side. You can't say HP because it's a side. So HG is a diagonal and PI is a diagonal. Number 6, every convex quadrilateral has, this is a convex quadrilateral, and it has 2 diagonals. Every convex quadrilateral. Notice this is convex quadrilateral. It has 2 diagonals. Convex quadrilateral here, 2 diagonals. Convex quadrilateral right here has 2 diagonals. And that ends the review on defining what a quadrilateral is. It's a polygon with 4 sides. And if you like my video, click on the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.